Today we will discuss about the conservation laws. Conservation laws. In this chapter, we will discuss about different conservations, which are of energy, momentum, and angular momentum. So let's start with the conservation of charge, which is a base of all these conservations. As if I talk about the total charge of the universe remain conserved, that's a global conservation of charge. But what about the local conservation? Global conservation, global conservation, total charge of universe remain conserved. But what about the local conservation? It seems to be, in a minute to you, a very strong statement. If the charge in some region, say which of some region changes, then the amount of charge must have passed in or out through any surface. So a local conservation of charge is a very powerful in terms of this global conservation of charge. Okay, and then start with the continuity equation. The charge, let's say the charge in a volume V is Q T V rho charge density, function of position and time d tau, and the current flowing through the boundary, say S boundary, current flowing through any boundary S is equals to J dot dA, which is equals to dq by dt. Now substituting the value of charge from the above equation to this, we will, and changing this by the divergence theorem, we will end up with this del dot J d tau and dq by dt d rho by dt d tau. And on comparing both sides, volume, curl rho by curl t is equals to minus del dot J. This is continuity equation. This, which is the mathematical statement of local conservation of charge, a mathematical statement of conservation of charge. Okay, thank you.